Hello and good afternoon to everyone. Today we are here to talk about the new ntopng version 5 and about the new features, the new directions that we are taking, and in essence what you are able to do and achieve with this version 5 release. It's a major release because we have worked several months to address many of the issues that we have identified and also to open new paths towards increased visibility and intelligence. Simone Mainardi, part of the team, will talk about that and will explain in detail this new release. This webinar is recorded and we'll put the video on YouTube after we have completed this talk. Simone?
Thank you, Luca. Thank you for the introduction. Let me share my screen. Okay, can you see the screen with the presentation?
Yes.
Okay, I'm trying to go full screen. Okay. Well, thanks, Luca, for the introduction, and thanks everyone for being here today. And yeah, today we are going to see the most relevant news that we have introduced after a few months of work on the ntopng, on the latest version of ntopng. So I'm going to start this presentation with an introduction and motivation. So basically, we are going to see what has brought us to this new 5.0 release, and then we are going also to see some of the new features in action, and specifically we're going to see the service maps, the alerts, and I'm going to wrap up this presentation with a brief discussion and conclusion, including the roadmap. So where are we going from now? And I will also announce a series of events that are going to take place in the next couple of months. The journey to ntopng 5.0. Well, ntopng has been originally designed as a pure passive monitoring tool. It means that it was looking at the traffic in the network and extracting metrics. Over the course of the time, what we have started adding active monitoring capabilities to ntopng. So we have added pings, we have added HTTP pings and SNMP and other active monitoring capabilities to combine the passive data with active data. That has increased significantly the visibility provided by ntopng. But still, we figured out that the intelligence provided with the tool was somehow limited. Because actually, okay, there were plenty of network metrics, plenty of information, but it was somehow like finding a needle in an haystack to just open ntopng and get to the relevant, to the most important information. And it was also required significant, I would say, significant skills in terms of networking, maybe, and security. So what we wanted to do into this release, into this 5.0 release, was to try and move from the pure visibility towards the intelligence. And let me present those two concepts in a quadrant. Intelligence and visibility are somehow two orthogonal concepts, I would say. And in this quadrant, I tried to put all the most widely known technologies when it comes to network monitoring and visibility. And as we can see from here, in the lowest end of the intelligence spectrum, we have technologies such as S-Flow, NetFlow, PCAP, that are per se technologies able to provide enough visibility of what is happening in the network, but per se are not enough to give you the intelligence to extract relevant information to tell you, hey, this is a problem, there is a security breach, or an application is slow. We also have IDSs and IPSs that are still, their intelligence, I would say, is limited because they are fingerprint based. They are mostly fingerprint based, and they are not able to correlate multiple events or to combine multiple events into a summarized information. If we go up in this quadrant toward the intelligence, we find the EDR and CM. And there's also the ntopng 5.0 that we can place somehow in the middle of this quadrant, maybe more shifted toward visibility. It is shifted toward visibility because it features the ability to monitor packets and to collect flows, so it has a significant visibility. But as I say, what it was missing was the intelligence, so the ability to crunch all this data into actionable insights. So this orange dot that you can see is basically where ntopng is now. And if you look at the orange arrow, that arrow represents somehow the journey of ntopng. So where it was, where it is now, and where it will be in the future release. So what we are trying to do is trying to shift ntopng from visibility up towards the intelligence as well. But the intelligence, what is the intelligence? It is, in our vision, the intelligence is the ability to automatically analyze network and security data and somehow limit the intervention of a human. And so basically we believe that intelligence is the ability to collapse thousands of signals into a bunch of aggregated indicators that can be summarized information, simple numbers, anyway, aggregated indicators that are simple to understand. Like traffic lights, I would say. You have 3 lights, red, orange, and green, and it tells you there is something bad, there is something so-so, there's some trouble, and all is good. So we wanted to translate all the metrics and all the visibility into something which is more simple to be understood and to be used to take actions, maybe to fix a thing or to solve a security issue. And let me just give you an example of what I mean when I say to collapse multiple signals into an aggregate indicator. And I would like to start with this first example, that is basically the introduction of the services in ntopng 5.0. So in this release of ntopng, we have collapsed basically the thousands or even the hundreds of flows that you can see in the old version. We tried to collapse them into more meaningful service maps. That is, maps with the ability to tell you the services that are active in your local network and who is using them. What is the meaning of a service, at least? I want to tell you how we have defined a service. For us, in our view, the definition of a service, at least the current definition of a service that we have created, is basically to take all the flows towards a particular service and collapse them actually by disregarding the ephemeral port. So let me give you an example. Let's assume that you have a web server running in your local network. Maybe that web server is contacted tens, hundreds, thousands of times, and that would result in having thousands of connections toward that web server. So you will somehow be overwhelmed by the data. So in our job, in the creation of these maps, we have just summarized all these thousands of connections to the web server with just a single entry that tells you, hey, this host is running a web server and this other host is using a web server. And in this slide, you see that actually there is an ntop web server used by an host called 192.168.246. And even though it has many connections toward the web service, in the service map, all those connections are collapsed into a single row that tells you client Simons is using server Devil on port 3000 using protocol TCP and top. So in this way, with this ability to collapse all the connections into aggregated lines called services, we were able to create the service maps, and we were also able to visualize them using a charts. So what we have created is the visual representation of the active and past services in your local network. So as you can see from this slide here, you have the active services, and there are also edges that are oriented. An edge or an oriented edge with an arrow means that an host is using a service running on another host. So you immediately have a graphical overview of all the services offered in your network and the users of the services. You have ability also to filter by protocol. For example, if you want to see all the HTTP and TLS servers in your network, well, you can take protocol HTTP and create a filter to only see the HTTP servers. So you can use protocols. You can filter services by choosing whether they are unicast or multicast, and you can choose the time, the observation period. You have a lot of filters. So for example, in this filtered view, we see that in the middle of this chart, there is host Devil. All the edges that you see entering and exiting Devils means they are services being used or offered by Devil. Let's focus, for example, on the thickest edge that connects the host at the bottom left of this slide called Simon's MacBook Pro with Devil. We see there is an edge from Simon's MacBook Pro to Devil, that unoriented edge, and there are two services here. There is SSH and ntop. Indeed, this means that Simon's, that is my MacBook Pro, was using services offered by Devil. Specifically, it was connected via SSH on Devil, and it was also using the ntop service on Devil. So with this view, you have a meaningful representation of the activities that are happening in your network. And this is good, but still the real intelligence comes with the ability of ntopng to automatically detect new and unexpected services, and also to notify with alerts about the detection of these new and unexpected services. And so to show you this intelligence of ntopng, I would like to give you a real example to demonstrate this ability to detect unexpected services. But before doing this, I want to introduce you to the concept of learning and post-learning phases that are used by ntopng to actually manage the detected services. Well, let me tell you that the service map that ntopng creates is created during a period which we called the learning period. That is a period of time that you can configure to be 1 hour, 2 hours, 1 day, or whatever, that is used by ntopng to create a baseline of all the active services that are active in the current network. So during this period, during the learning period, we say that ntopng is in the learning phase. After the learning period, we say that ntopng is in the post-learning phase. So in both phases, you have the ability to specify the behavior of ntopng. That is, for each service detected by ntopng, you can either choose that service to be considered allowed, to be considered denied, so unwanted, and in that case, you will receive alerts, or you can also decide that the service is undecided because it requires human intervention. And you can configure those three statuses both during the learning phase and in the post-learning phase. And now that I have introduced this concept, I would like to show you an example of what happens when an unexpected service is detected. And specifically, I'm going to start an HTTP server and try to connect to this unexpected HTTP server. But first of all, I need to configure ntopng and tell it to consider all the new services detected in the post-learning phase as denied. So as you can see from this preference, I've changed the service status from allowed to denied for the post-learning phase. This is the only thing that instructs ntopng to react and alert upon the detection of denied services. What I've done then has been to spawn an HTTP server on port 7800. I just simply use Python 3-m http.server 7800 to spawn an HTTP web server on this machine. And as we can verify from the netstat, the web server is running and listening. Then I went on another machine, actually on my MacBook Pro, and I tried to curl the HTTP server running on Devel. So as we can see from here, from this slide, we say curl HTTP Devel port 7800. There's a response, the HTTP response, and we can confirm our web server has received the request from the log at the bottom of this page. So this is an example of a web server, but that could have been a web server spawned by a malware or spawned by a misconfigured host, something that you want to detect because you, as a network administrator, you must be aware of all the services that are currently active in your network. So what happens here? As soon as ntopng has detected this new service, this new HTTP service, it immediately marks it with a big red arrow going from Simmons to Devel. And indeed, we can see this arrow that says SSH and HTTP, and the arrow is red because the HTTP session is marked as unwanted. This is useful, but sorry, there is someone with a mic on. And
Simone, we cannot
so
hear
yeah. Sorry, there was someone with a mic on, and I just tried to mute. Sorry about that. Okay, so can you hear me okay now?
Yes.
Okay, so as soon as the unwanted service is detected, it will be marked with red. So this demonstrates the ability of ntopng to detect unwanted service, but Clearly, we don't want only the unwanted service to be detected. What we want is also to receive a notification, to receive an alert that notifies us, that notifies the network administrator that an unwanted service has been detected. And this is the activity that ntopng performs actually. Indeed, when it finds the unwanted service, it creates an alert that we have called lateral movement. Lateral movement because we assume there is a movement in your LAN between a host and a service, and you get the alert, and you can also decide to deliver the alert to downstream recipients such as Slack, Discord, email, or other channel. So since I've mentioned alerts, I would like to spend some slides also to demonstrate how the alerts have changed between ntopng 4.2 and 5.0. Because actually alerts are the way that is used by ntopng to notify you about the results of the network intelligence it runs. So with alerts, ntopng continuously monitors the network for network issues and security issues. It applies the intelligence, and then if it detects something that is worth being told, it creates an alert. So we wanted not only to work on the intelligence, on the part of the intelligence of ntopng, but we also wanted to work on the alerts engine, because in the earlier version of ntopng, alerts were not that flexible because they were mainly a plain list with all the events, and it was very hard to look for events, to search on that list, and to really have an overview of the issues and to use the alerts to drill down a possible security or network issue. So what we have done in this version of the ntopng is that we have transformed this plain list into a rich alert explorer with a lot of features and a lot of filtering capabilities that we are going to see now. First of all, we have divided the alerts into families. So we have hosts, flows, interfaces, and other families. And this is just a first way to give categories, to keep things organized. Things that were previously all mixed up in a single log are now more organized. Then we have also provided a summary, as you can see here, so that for each family, you can see the things that are okay, the things that are so-so, and the things that are bad. So if you recall the first traffic lights that we have seen at the beginning of this presentation, this is basically the traffic light, because all the intelligence run by ntopng is summarized in this table. And for each family, it tells you the green, the orange, and the red. 3 lights for things that are not relevant, for things that are potentially relevant, and for severe issues. We have also divided and offered 3 different views for the alerts. Specifically, we have the past alerts, where you will find all the alerts that happens at some point in time but are not currently ongoing. We have the alerts called engaged. It means that our alerts that are happening right now, that are network and security issues currently ongoing, currently happening now when you open this dashboard. Then there's a third family as well that is called the acknowledged alerts, that are basically alerts marked by a network administrator as acknowledged, and we are going to see them in a while. We have also provided an overview of the alerts in time and in terms of topics. So you have visibility of the distribution of alerts and their severity in time using this chart. But thanks to the ntopng functionalities, you can immediately know who are the top sources of troubles in terms of hosts and what are the trouble sources, because you have the top alerts. In these examples, we have the suspicious device protocols, remote access, and other alerts as well. As I mentioned a few minutes ago, we have also provided a pretty flexible way to filter the alerts, because we wanted to have a tool flexible and powerful enough to be able to extract what you are really looking for. So for the alerts, you can create and combine filters using, for example, alert types, security score, a specific host, a specific destination port. There are many, many filters available that you can choose to really find what you are looking for in the alerts that can potentially be a very large number. We have also extended the alerts with security features because in the intelligence run by ntopng, it has the ability, at least for certain events, to tell whether there is an attacker or a victim for that particular event. And when ntopng detects that this event has an attacker or a victim, is able to mark this event with a flag. This is an attacker, this is a victim. And it gives you the ability to filter the security events from the others as well, using attackers and victims. Another important thing that we have added here in the alerts is the ability to exclude certain alerts. This was a very important feature. I mean, many of our users and customers was demanding this feature because it's important to be able to selectively disable certain others. Because, I mean, you know, in a real network, there are always things that are unfixable. Maybe you have old TLS certificates, an outdated web server that you cannot change, that you cannot touch. But at the same time, you don't want to receive alerts for that particular service or server because they will pollute the alerts, the relevant alerts, with alerts that you don't want and you don't recognize as such. So for example, here I have, let's assume that Devil in these examples is a Bayesian host that you are using to access your VPN in the cloud. So you can have a remote access alert on, so that this remote access alert notifies you every time someone is trying to access an SSH service in your network. But you want this alert to be disabled for Devil because Devil is your SSH server and you want that server to be used as an SSH entry point for your network. So what you can do here, you can click on the bell icon and tell ntopng, hey, I want to disable remote access alerts for host Devil. So what happens is that your network continues to be protected because you keep receiving remote access alerts for all the SSH access in your network, except for Devil. Because Devil, you have explicitly disabled the alert for Devil because you want to let people access SSH to them. So this is a particularly relevant feature. And this also allows me to introduce the concept of acknowledged alerts, because let's say that we have disabled the SSH, the remote access alerts for them. So now we recognize that remote access alerts for Devil are something that is past, has been handled, and so we no longer want to see it among the alerts that we have. So what we can do is just pick the remote access alerts between CMOS, MacBook Pro, and Devil, and say acknowledge alert. In the acknowledge alerts, we can specify a comment, for example, SSH allowed to Devil, and then we click on acknowledge. So at this point, the acknowledge alerts get, I would say, archived. They are put in a different part of the database so that you will no longer see them among the alerts unless you want to explicitly search for acknowledge alerts. And these alerts are also the powerful of these alerts is also the ability to have them delivered to downstream recipients. So alerts are not a concept that stays and lives only inside ntopng, because we want ntopng to be as open as possible. So alerts can be delivered to your downstream store, to your email, Slack, Discord, and many other recipients that you can configure. In this example, I have an alert received on my Discord channel, but you have many other endpoints, including Elasticsearch, email, Slack, and so on. Another new that we have introduced in this ntopng is what we have called the score. This allows me to connect to the beginning of this presentation, where I explained that our vision of intelligence is the ability to collapse multiple signals into a summarized indicator. And this is another example of intelligence that we have placed in ntopng. Because with the score, we have created this number, this score, that collapses both network and security metrics into a single indicator, into a single number that has the ability to tell you if a flow or an host or an autonomous system or another network element is good or misbehaving. And the way this score tells you this is just with a simple and single number. So if you have a 0 score, then there is no issue and everything is okay. Then if you have a low score, then there is something that should be inspected. And if you have an high value of the score, that definitely means there is something wrong with that particular host or flow. And remember that this is just a single number that collapses hundreds of checks corresponding to both network and security metrics. And I mentioned checks because checks are what ntopng uses to actually calculate the score and to create alerts. Checks are applied for hosts, flows, networks, interfaces, and all the other network elements. And they all concur to the creation of the final score. So you have, let's say here we can see flow checks. So all these different things are run for each flow. For example, for each flow, we analyze if it comes from a blacklisted country, if the user has been used that particular connection with clear text credential, if this particular connection is a potential data exfiltration. So all these checks contribute to the final score of the flow. So the higher the score, the higher the chances of that flow to be suspicious. The score, it's really a wide argument. So we have decided to treat it in a separate event that is going to be later this October. So for now, just I will just give you a brief overview. Then if you are interested in knowing more about these very interesting metrics, then remember to join us for another session. It's also interesting to see the integration with fail to ban in ntopng, because a few slides ago I mentioned that there are some checks that are able to, ntopng with its intelligence is able for some checks to tell you if there is an attacker performing an HT activity. In this case, if you enable the integration with fail to ban, and ntopng detects that an host is an attacker, there is an automatic action where ntopng tells fail to ban, hey, you have to block me this host for a certain period of time. So it's not only a matter of being purely passive with these checks and with this intelligence, because now ntopng has also the ability to block hosts by integrating with, for example, fail to ban. Among the other news that we brought with ntopng, we can find a reduced load. Our experiments have demonstrated load reduced by approximately 1/2 between ntopng 4.2 and 5.0, and we were also able to distribute the load more evenly to mitigate the periodic spikes that were occurring at regular intervals of time before this release. There are also news when it comes to the flow collection, because many of our users use ntopng in combination with nprobe to collect netflow, sflow data from their routers and switches. So this new release of ntopng brings the capability to collect flows at a sustained rate of 100,000 flows per second. It means that you can have this software combined with ntopng to monitor net flow traffic in your enterprise up, let's say, to 85 megabits per second. That is approximately 100,000 flows per second. This is also an increase by 15% with reference to the previous ntopng 4.2 release. In terms of flow collection, we have added another interesting concept to the latest version of ntopng. And this is the concept that we have termed observation points. This is useful, especially in large enterprise environments where you have to monitor hundreds of routers or switches. What is this concept of observation point? It's a logical aggregation of multiple routers into a single group. Let's see this concept with an example. For the observation point, we can consider an example of an enterprise that has a branch in Rome with 3 routers, a branch in Paris with 1 router, and a branch in Berlin with 2 routers. From the point of view of the analyst is interested in looking at Rome's traffic, at Rome's flows, regardless of the particular agent, regardless of the particular router those flows are coming from. Similarly, the analyst is interested in looking at the traffic from Paris or from Berlin. So with the observation point, we are able to show you in ntopng, like a filter, to automatically select all the flows that correspond to a logical aggregation, that in this example are the branches of an enterprise distributed in Europe, but can be other criteria and other aggregations as well. So especially when you have hundreds of routers, this is very useful to have logical groups of flows originating at some group of sources that is relevant for you. Finally, we also added support for new platforms in ntopng because we wanted to extend the capabilities of our tools to the firewalls, to the firewall communities, basically. And this is why we've added support for OPN Sense and PF Sense. And if you are using this with OPN Sense, there is also a plugin that allows you to configure the service straight from the user interface of OPN Sense. There is also support for FreeBSD versions 11 and 12. So this concludes basically the main new features that we have introduced. So where are we going from here? Well, from here, we are trying to continue the transition from visibility to network intelligence. So as you recall in the first slides where we have seen the arrow, we are trying to keep moving towards intelligence in the quadrant that we have seen at the beginning of this presentation. We're also trying to improve the intelligence and the checks run by ntopng using learning and fitting to combine approaches with static thresholds with dynamic thresholds learned during the execution. We're also extending the service maps, trying to show the differences in times and the ports that have been opened by the hosts. And likely we will combine these with the data, with the new data coming from nprobe. That is data that gives us the capability to map the ports open with a specific process. So this gives us the ability to not only to know that there is a certain port open on this host, but also which is the process that is using the open port. This is basically the continuation of a work that was initially presented under the nprobe agent, which was a part of nprobe dedicated to these activities. We are also evaluating the integration of ClickHouse, both to store alerts, because now alerts are stored in SQLite, but we have seen that SQLite, especially in large-scale environments, it can sometimes fall short when it comes to having many writes per second. So we are considering to use ClickHouse for alerts and also for flows. I would say as an alternative of an index that we currently use to store flows in ntopng. There will be also other activities in the roadmap, but they are going to be announced in a forthcoming event, so stay tuned. I wanted to announce also the training of ntopng because we have received many inquiries and requests from users and customers to have a training of ntopng. So we have decided to do this training, and this training is organized in 5 daily sessions. Each one will be 1 hour and a half, and those sessions will be held in the month of November. So if you are interested in the training of ntopng, you should consider attending the training, and in the training we will see the installation, licensing, and we'll see how to tune and configure ntopng to always get the best results in any environments and given a specific hardware. And then we will also investigate all the features and the new things that are always continuously added to the software. Finally, this is our calendar of the forthcoming events. So October 26th, at the end of this month, as I mentioned earlier, there will be an event dedicated to the score and to the security features of ntopng. So Luca will go very deep into this argument to explain how we calculate the score in detail, how we turn the red, yellow, or green lights of the semaphore. So this will be a very interesting event. You should save the date to go deep down into the security features of ntopng. Then during November, there will be the 5 days of training. All the days will be from 3 p.m. to 4 in the afternoon of the European Central Time. And eventually, in a date that still has to be announced, there will be the ntop mini conference. That is our yearly event where we discuss about all our products. We have new drivers developed by Alfredo with the Mellanox. We are working on an EDR. So there will be many news presented during this mini conference. And yeah, if you are following us on our channel, Discord, Telegram, you are following our blog, you will get the announcement of the date. So this basically concludes my presentation. I would like to thank you for being here. And yeah, all the developers of ntop are here attending. So if you have questions, if you have feedback, we will be very happy to respond and to discuss ideas and features with you, because we are all tuned here at this event. So thank you. I don't know, Luca, if you want to add something, or if you guys have questions. Yeah.
Yeah, there is a question for you, Simone. Can you please elaborate why there are several parts of the session for training? 5 parts. Please explain a little bit how it works and what is the content.
Yeah. Okay. We have 5 parts, and I can send you the URL. I can just show you the URL here with the program, basically. So I don't know if you can still see my screen. So this
we see the slides.
This is the URL of the training. You can check it out. And basically, there will be 5 lessons. So the first part is just an introduction. So how does ntopng works, and what are the ways that you can use ntopng to have visibility and intelligence from your network. So in the first part, we discuss the deep packet inspections and the analysis of packets, and then we also discuss the flow collection. So when you use ntopng in combination with nprobe. Then in the second part, we are going to see the installation and licensing. So how to install ntopng in the most common platforms, and how does the licensing work, because we have several levels for the licenses. We have the Pro, the Enterprise M, the Enterprise L, the bundle. So we will dedicate some time to discuss how does this work. Then in the third part, we are going to go deep into the network intelligence capabilities of ntopng. So how does the check works? How does the score work? The exclusion lists that we have seen earlier in this presentation. In the fourth part, we dedicate the fourth part to the collection of flows. So basically the use of ntopng in combination with nprobe. And finally, in part 5, we dedicate 1.5 hours to explain all the historical data. So how ntopng stores and gives you access to the historical data. So we are going to see the time series, the alerts, the flows, and even the packets. So all these things are used by ntopng to store historical data. Of course, there are pros and cons between one alternative versus another. And we are also, so using this last session, we are going to see all the differences between those storage ways, those ways to store historical data in ntopng. Are there any more questions? What's the Telegram channel? You can find our Telegram channel. Let me take the link. So this is the, here you will find our official Telegram channel. We are very active both on Telegram and on Discord. So yeah, feel free to join our channel. Okay.
I think I've answered all the questions, Simone.
Say it again, Luca.
I think I've answered all the questions.
Okay.
On the chat. I see no more questions, so I think if you want, you can wrap up and close this event.
Okay, yes, so thanks everyone for being here, for attending this event. Yeah, feel free to visit our page if you want to install our ntop, you can visit this page, and there are packages for several distribution. Just visit this page and give it a try. And thanks everyone for being here, and stay tuned. So yeah, there will be many additional events by the end of the year. So we'll be happy to have you. And yes, thanks everyone for being here. Thank you.